Science 10, welcome to video lesson number 3 for physics. We're going to jump right in down here. This is where we left off. I really wish that the start of this video was attached to the end of the last video in hindsight, but that's okay. We're going to put it in at the start of this one, okay? So you should be up to page 16 in your note packet. Notice that number 7 is on the back side of actually page 17 of these questions, so just keep that in mind, okay? So moving on. This is a big importance, so this is why it's highlighted underneath, okay? You need to know the difference between speed and velocity. Must know that. This is what I was talking about at the very start of the last video. So the difference between speed and velocity is speed uses distance, velocity uses displacement. Okay, and we understand the distance is a total area traveled, okay, and it's a scalar quantity, while displacement is just a straight line difference between position of object 1 and position of object, or final position subtract initial position is the way that I'm going to say it, okay, and it is a vector, okay. Throughout the unit, we're probably going to be using these two things pretty interchangeably, but it's important that you know the difference. And by the way, this box here, if I'm not mistaken, is actually the answer key to the 7 questions you just did, and they're in your notebook. So these are the two equations. Speed is distance divided by time, and velocity is displacement divided by time. So those are the two differences, okay? So make sure that you know whether you're solving for velocity or speed. Okay, so example, if Freddy Krueger is, this is the example I was looking for. Okay, so we're talking average velocity here, okay, and this is just a little more complex because initial time and initial distance is not 0, okay, so initial time is 1.05 seconds, final time is 4.55 seconds, so total time would be 3.5 seconds. So it's TF subtract TI initial to get total time. Okay, and displacement is the difference in the points, and obviously it's going from the fronts of the car. This line's measuring the front of the car, so we need to measure from the front of the car here. It's saying that this car is 3.25 meters, so you start there, okay? So distance final is 56.23, so you'll be 56.23 minus 3.25 to find your delta D, okay? So to solve this problem, this is what it looks like down here. Change in delta, so you can remember these little arrows right here that are above are stating that it is a vector quality, okay? So change in distance over change in time. So there's the numbers that I just wrote out for you, okay? And once you get your equation, it becomes 15.1 meters per second right. And in this one it's going right. There is an arrow. It doesn't say whether that's east, west, or north or south, but it is saying that it's going right. So it is a vector quality, okay? So that is velocity. Okay, so having known the difference between velocity and speed, velocity and speed, you can now do up to page 19 in your note packet. Okay, so go ahead and do that now, please. Remember, if you've got a really good grasp on something, you can feel free to not bothering doing every single practice question the whole way through because it can be time consuming. So feel free to just read through the question, say, oh, I know how to do this. I would just do this, and just do it in your head rather than going through it once you've mastered it. But make sure you at least read all the questions, say, oh, this one's a little bit different, and then try to work through that one, even if it's a 7th out of a 10 question, because it might just throw you for a loop and see a ripple that you might not have seen before. So now we're going to go into graphing. We always talk about graphing with everything. Okay, so there's 2 types of graphs. So we're talking about uniform motion. So the motion is indicated by a linear position time graph or a distance time graph. So it's going to be one of these 2 types of graphs. Okay, the slope of a distance time graph, so this, okay, is the average speed or velocity, okay? So that's how fast it's going at the time. Uniform motion means that velocity doesn't change and velocity time graph is horizontal. So if something's in uniform motion and you're describing uniform motion and it's velocity time and it's a velocity time graph, this line is going to be going straight across because that's showing. So velocity over here will be speed, okay, and this will be like time in hours. So it'll be 80 over here kilometers an hour, and if it's uniform, you know it's remaining the same, so it'll always be a parallel line, okay. The area between the line and the x-axis is the distance or displacement of the object, okay? So down here, so for this one right here, the area underneath the graph at any given point is the distance or displacement, depending on whether you're talking about velocity or speed over here, okay? It's going to be the distance or the displacement. What that means is, let's say you want to find out how far that this has traveled at this point. Let's say this is at 3 hours or whatever. You just simply find the area underneath the graph, okay, and that's how far it's traveled, or the total displacement, depending on which equation you're doing, okay. That's what this area underneath this chart represents. Same with over here, okay, so you're going to find the area underneath, and the area underneath here is speed or velocity, so it's the opposite. Remember, when you're finding area of the triangle, it's base times height divided by 2, whereas the rectangle is just base times height, okay? So remember that part, okay? So at this point, I think you guys are good to do up to page 26 in your note packet. I know that seems like a lot of pages, but graphs take up a lot of space in there. There's actually, it didn't quite, if yours looks like mine, which it should, there's actually some printing errors where there's some actually pretty much completely blank pages in there. And so there's not as many questions as it would seem. So you should be good to do up to page 26. Like I said, please remember, you do not have to do every single question fully, okay? So don't overwhelm yourself by doing too much here, okay? If you do get through them all and you would like some extra practice questions, these are from your textbook. That could be said. If you don't like the questions that are in the note packet, you're not understanding them, you might be able to go to the note packet as well, or the textbook, sorry, and there might be answers in the back or different descriptions on these pages as well. Okay, so that's your MIDI lesson here. Next time we're going to talk about acceleration. See you next time.